All right, today we're going to start lesson 3.1. This lesson is going to be on statements, conjecture, and compound statements. We're going to start to just identify statements and really how they apply to geometry. Obviously, we're going to look at what conjecture is. We're going to look at some compound statements, identifying them. And we are going to do a little bit of truth value today as well. Okay, so we'll start with some terms and definitions. First of all, a statement mathematically or statement anywhere is any sentence that is either true or false, but it can't be both. It's got to be one or the other. Okay. So statements are often represented mathematically using letters such as P or Q. So they'll just say P represents this statement, Q represents this statement. Okay. The truth value is just identifying whether the statement that's given is either true or false. It's got to be, something that can be concluded to be true or false. And then the last thing we're going to look at here, which goes with this, is negation. The negation of a statement is a statement that has the opposite meaning of the original, as well as the opposite truth value. Okay. So if we had the statement, for example, the moon is blue, that's false. Okay. The negation would be the moon is not blue, that's true. So it's got to have the opposite meaning and the opposite truth value of whatever statement it is they give us. Okay. When we write negations, we put this little tilde sign here in front of the P. So we either write not P or this little symbol in front of the P. Okay. So let's talk about statements first. So for each statement, determine whether it is truly a statement or not. Turn off the TV. Okay. That's not a statement. Okay. That's a command. It's not true or false. It's telling you to do something. Okay. So this is not a statement. Ha. Again, this is an exclamation. It's not neither true nor false. It's just a exclamation. Somebody said ha. So that's not a statement. 8 times 5 equals 40. This is a statement, right? This is either true or false. And in this case, it's true. Okay. Who's making dinner? That's a question, right? It's not a statement. It's neither true nor false. The moon is the smallest planet. That's a statement, right? This is either true or false. Okay. It's either true or false. I think it's false. I think Pluto's the smallest planet. Okay. So, anyways, that's how you identify a statement. It's got to be something that you can conclude to be true or false, but it can't be both. Okay. Looking at negations of statements. Remember, they got to have the opposite in truth value. So, this is going to ask us, let me just go through the directions. There are several statements below. For each, determine whether it's the negation of this statement. X is equal to 50, or excuse me, X is equal to 500. So they're telling us X is 500. Okay. Is X is equal to 200 the opposite in meaning of X is equal to 500? Well, no, right? Both statements are false if X was equal to 300. Remember, we can't have a negation that can have the same truth value. So if I said, all right, X is equal to 500, I say X is 300, well, that means this one's false and this one's false. That's not the negation of it. X is not equal to 500. Well, there it is, right? That's very directly said. It's the opposite in meaning of this one. So X is equal to 500. The opposite in meaning is X is not equal to 500. Okay. X is not equal to 200. Well, that's not going to be the opposite of meaning of this in all cases. All right. So that's false. Okay. That's not the negation. It is not the case that X is equal to 500. Well, this is a fancy way of saying X is not equal to 500, right? And that's the opposite of meaning here. So yes, that is a negation. So negations are pretty straightforward. I think you'll see it. You just got to make sure that it directly says the opposite of meaning of the original. Okay. All right. Now we're going to look at compound statements. So we're going to take compound statements are when we join two statements together. We can join them 4 different ways. We can join them with the word and, the word or we can use phrases to connect them like if this, then that, or this, if and only if that. Okay. So, how do we identify the compound statements? Well, the first one is what we call a conjunction. A conjunction is when we build this compound statement with the word and as a connector. Okay. So, if the word and is a connector, it's a conjunction, and it's only true when both statements are true. Okay. So, the and conjunction is restrictive in the fact that it's only true when both statements are true. A disjunction is a compound statement when we connect the two statements with the word or. Okay. And this is only true, or this can be true when at least one of the statements are true. So this or that, if one of this or that is true, then we consider this whole thing to be true. And we're going to go through a lot of this, so don't worry about it right this second. Conditional statement. Okay, a conditional statement is the if then. It's a compound statement, so we're joining two different statements together. If this, then that. That's called a conditional statement. Now, we kind of look at this one backwards. A conditional statement is only false if the hypothesis is true. Now, the hypothesis is the part that follows the if. And we're going to go through this later, guys, so don't get too worried here. So the hypothesis is the part that follows the if. The conclusion is the part that follows the then, the statement that follows then. So this thing is only false. The only case in which it's false is when the hypothesis is true and the conclusion is false. Okay, we're not going to get into a ton of true false values of this. I just want to get it out there to you now so you see it. A biconditional statement is when we join two statements together with if and only if. So this happens if and only if that happens. So those are the two statements. Okay. Now, this one is true when both of the original conditionals are true. And again, we'll talk much more about this later. I just want to be able to identify these right now. Okay. And let's do that. For each statement, choose if it's a simple or a compound statement. And if it's compound, choose which type. So, twilight is my favorite time to sit on the porch. Is that a statement? Yeah, that's a yes or no thing, right? That's a yes or no. Is there any connectors in it? Do you see an and or an or an if then or an if and only if? No. So this is just a simple statement. It doesn't have any connectives to it. There's not two different statements there. Next example, the sun is up or the streetlights are on. Well, obviously we got or right there, right? So this is a compound statement. And because they use the word or, it is a disjunction. This drop down menu will let you say disjunction. She will buy a car if and only if it is yellow. So this is a compound statement because we see if and only if. There's a connector there. If and only if, compound statement, and it's biconditional. If and only if is biconditional. If you look at the last page we just went through and listed those different types. Okay, so you'll get some of these tonight. Okay, this brings us to inductive reasoning. Okay, so inductive reasoning is the process of reaching a conclusion based on patterns of examples. Okay. And so when you see this pattern of examples and you think it's going to continue, then you make an educated guess on what you think that pattern will be from here on out. And that educated guess is called the conjecture. Okay. So this conjecture concept is a conclusion you draw from what we call inductive reasoning. And inductive reasoning is simply studying information, looking at examples and saying, hey, I think this is what's going to happen. It's called an educated guess, okay? But we call it a conjecture, okay? The way you're going to work this today is they're going to give you a conjecture, which is a statement, okay? And then you're going to determine whether it's true or false based on a possible counterexample. And a counterexample is simply an example that you find that shows the conjecture is false. And it only takes one, okay? So this whole concept of inductive reasoning is simple. It's just a process of studying information and drawing a conclusion. And what we're going to be working on today is looking at these conclusions, which we call conjectures, and determining whether we can find a counterexample to prove it false. Okay, for example here, show that each statement is false by providing a counterexample. Okay, so this is a someone made this up as a conjecture. If angle 1 and angle 2 are complementary, it means they add up to 90. Then one of them must have a measure greater than 45. Okay, so the question to you is this true in all cases? Is there any case you can think of in which this isn't true? And well, you got to come up with this one. If they're both 45, they're going to add up to 90. And one of them isn't greater than 45 because they're both equal to 45. Therefore, this counterexample right here proves this conjecture or this statement false. That's all you're trying to do. Okay, so you're really digging into it and trying to find the one example that could make it false. If the perimeter of a rectangle is 28, so when we add up its four sides, and remember in a rectangle, opposite sides are the same length, right? So if the perimeter of the rectangle is 28, then the length has to be 10 and the width has to be 4. So 10 plus 10 is 20, 4 plus 4 is 8. This adds up to 28. Yeah, that's true. But does it have to be this one? Well, come up with a counterexample. 12 and 2. Okay, 12 and 12 is 24. 2 plus 2 is 4. 24 and 4 is 28. Therefore, this rectangle, the one that length of 12 and a width of 2, is the counterexample to this conjecture, this conclusion that was drawn. If the measures of angle P, Q, and R have a sum of 180, then all the angles have to be acute. So these three are going to add up to 180, and they all have to be acute, which means they all have to be less than 90. Well, that's pretty simple to come up with an example here, right? I did 20, 20, and 140. Okay, 20 plus 20 is 40. 40 and 140 is 180. So yes, I meet the requirement. All three add up to 180. However, R here is not acute. So this is not a true conjecture. This is not a true conclusion. So that's what we're trying to do with this. All right. Next thing we'll do is use some symbols to write these statements to get the feel for how to write these different compound statements using symbols. First of all, I mentioned earlier that what we do is we take a letter and we represent a statement with it. So P, today is Tuesday. That's a statement. It's true or false. Q represents this statement. It is raining outside. Well, look outside. It's either true or false. Okay. Now let's talk about how we use symbols to write statements. If I wanted to negate P, the negation of P, I would do this little tilde P. Okay. That's negation of P. What would it mean? It would mean today's not Tuesday. Pretty simple. Negation of Q. Again, little squiggly in front of the Q. What does that mean? It's not raining outside. If I wanted to write the conjunction of P and Q, well, we'd want to join these two statements with the word and symbolically, we use this little it's a little power symbol, really. I think of it as a letter A without the little thing across. That reminds me that it represents and. So what this symbols mean is take statement P and join it with the word and with Q. So what would it be? Today is Tuesday and it's raining outside. Disjunction, that means use or. So or is going to be a V here. So it's flipping this one upside down. So P or Q, today is Tuesday or it's raining outside. A conditional means if then, right? So we write conditional. The symbolism for conditional is this: if P, then Q. We use this little arrow. If P, then Q. And we would write, if today is Tuesday, then it's raining outside. A biconditional means join these two together with if and only if, and the way we write it is this. So what it's saying is if Q, then P, or if P, then Q. But how we write it over here is today is Tuesday, if and only if it is raining outside. So we're joining our two statements together with if and only if. So that's how we write them with symbols. And you're going to see these symbols given to you and be asked to write them that way. So again, we're still working with statements. We're just using symbols. All right, consider these two statements. P represents the statement, it is Tuesday. Q represents the statement, there are students in the classroom. For parts A and B, fill in the symbolic form. For part C, choose the descriptive form. All right, so how would we represent there are students in the classroom or it's Tuesday? There are students in the classroom is Q, or is the V symbol, it's Tuesday P. So Q or P is how we'd write that. Today is not Tuesday. Well, that's the negation of P. What is this? This should say it's P and Q, right? So it should say it is Tuesday and there are students in the classroom. Just using the symbols and these statements to write it out. Okay. Another set of these. P, the truck is on the road. Q, the valley is below us. Same deal. The truck is not on the road, but a valley is below us. Now, we didn't really use the word but if you look through some examples, but is like and. Okay. It's like and, joining it with and. So the truck is not on the road. That would be the negation of P. And the valley is below us. So it'd be negation of P and Q. Now, B is interesting because this is actually going to force us to group it. It is not the case that, and then in italics here, not italics, what do we call those? Apostrophes. No. Man, I forget what that's called. Anyways, it says a valley is below us or a truck is on the road. So a valley is below us is Q, or the truck is on the road, so that's the V, right? But we want the opposite of this. So we're going to group this Q or P. I'm going to group it, and then I'm going to take the negation of that answer. That's what it's asking us to do. Parentheses, these are called parentheses. Okay. Then part C, negation of Q or negation of P would be the valley is not below us or the truck is not on the road. Last of all, kind of using our counterexample concepts, and well, actually no, we're just using our symbolism concepts to apply to a situation. So here's this circle graph, and this circle graph is representing the how a company divides up its annual budget. You can see support, research, sales, engineering. It breaks it into this pie chart. It says, let's consider these statements for this pie chart. The company budgets more money for engineering than support. That's a statement because we can go over here and look and see, is that true or false. Statement Q, the company budgets the least amount of money for research. Again, we can look over here and see if it's true or false. We'll do that in a minute. First question, write the following statement in symbolic form. The company budgets more money for engineering than support. That's statement P. And the company budgets the least amount of money for research. So this would look like P and Q. Pretty simple. Part B, based on the information in the circle graph, complete the table to determine the truth value. Okay. Statement P, is that true or false? The company budgets more money for engineering than support. So engineering is $100,000, supports $145,000. So this statement is false. Q statement, the company budgets the least amount of money for research. Well, research is 40,000, everything else is more than that, so that's true. Now, what's the truth value of P and Q? We haven't done a ton of this yet, but if we're going to use the word and, then the two statements that make up this uh, concept have to both be true. So and has, for this statement to be true, it's got to be true and true. Well, this is false and true, so it's false. Okay, so just working through that. Okay, so there's a little look at statements and conjectures and compound statements using some symbolisms. Hopefully, you wrote down some notes and you use those notes to help you with homework. Okay, uh, take your time, work through it on Alex. I think it's all pretty straightforward stuff. I think you'll do great, and I will let you get at it.